Thanks a lot for inviting me to speak here for this opportunity. I have to admit some points. I will not talk about the cooperations that we already have. There are a number of them. We have seen them in the presentations. Rather, I would like to talk about things that might happen in the future, and I have to apologize to all those who know already about CREST. I will take some time to present this SCCR. I think that's a good opportunity so that all of you know here what we do. I will try to be fast, and if I take too long, just stop me. So what is CREST? We already heard about topics like promotion of renewables, subsidies for renewables, and it seems to stir some kind of discussion. And that's one of the major topics we're talking about in CREST. CREST is a one non-technical SCCR. So what we do is not to look at what are the great new technologies that will make the energy transition happen. That's your work. What we are going to ask is a question: what kind of markets, what kind of policies are necessary so that new innovative ideas really get a fair chance? So what needs to be done so that PV is not just, let's say, the new hype for the next 3 years, or that something like these storage systems that we've seen today can make it to the market. I will do this by briefly talking about CREST first. I will show you CREST. Then I will give you 3 examples. And again, I have to say these are not representative examples in the sense that they represent all of CREST, but they just should give you an idea of what we are doing. And finally, I will come back to CREST and talk about the connections to the topics related to what you are doing here. Now, I already said the vision of CREST is not to produce new technological ideas, but to show what kind of markets, electricity markets or energy markets in general, what kind of policies are helpful to make the energy transition happen. And I think that's the most important part of our work. If you look at this map in the right-hand corner, that's the electricity price map of Switzerland. So we see it's kind of fractioned. We see many different prices in different regions. And one of the topics we are discussing is this a good map? Or should we have market liberalization that perhaps leads to a unified price for electricity in Switzerland? What is a better system? And that's really an open question. Nobody knows at the moment. So finding the right political, economic, legal and social condition, that's one of our main topics. The second one is to formulate recommendations out of this knowledge, to say what kind of policies are not just ideal, but what kind of steps could be made in a reasonable way. What is a way forward to move for Switzerland? What are good policy recommendations? And what a good recommendation for firm strategies? Is what we've just seen, is this a great strategy, or perhaps is there something that could be done in a better way, even better way? So what are good strategies? And our idea is not just to produce recommendations. I think most consulting agencies can do this much cheaper, perhaps not much cheaper, but much faster. But to provide tested recommendations, to really go into the field and test what might work before we make recommendations out of this. And finally, we will support some general information to firms, regions, public administration. For instance, what's likely to happen with electricity prices in Switzerland within the next years, things like this. We're working on 3 main fields. The first one is promotion of renewables. You already heard the current system of feed-in tariffs is likely to be abandoned at some point in the future, 2021 or somewhat later. And one of our topics is what should come after this. What should be the next system? The second topic is reduction of energy consumption. The idea is to reduce energy demand per capita by 43% within the next 21 years. That's a fairly ambitious target. I think there's no country in the world that has ever achieved this voluntarily. Some countries have achieved this by means of civil war or prolonged recessions. I think that's not the kind of recommendations we are likely to make for Switzerland. So we need to find different ways to do this, and that's one of the topics we're working on. And finally, assessment tools. If I talk about good policies or not so good policies, we need to define what means good in a national economic sense. So we need simulation tools and tools for field experiments to see what kind of policies work or do not work so well. CREST is structured in 3 main work packages. I will start at the bottom here. That's the macro work package. It's on the national or cantonal scale. We look at policies, markets. Mostly this is a simulation-based exercise. Then we have on the other extreme the green one in the middle. That's the individual level, looking at how can energy consumption per capita be reduced. And in between we have work package 1, the yellow one on top. That's a meso level, as we call it. That's a level of firms and regions. That's something where we look at regional strategies, new business models. Are these solar roofs that you offer, is this a good business model, or what could be done here? That's a kind of research we are doing. Now let me give you some examples before I come back to this. And I want to give you 3 brief examples of work we are currently doing. The first one is about innovation. And I've chosen this example because it's an example of what we do as kind of basic research. The idea of innovation is, in the energy sector, that innovation is not happening, mostly at least, not happening by itself. It's triggered by policies, it's triggered by specific measures. In a certain sense, all of these SCCRs are triggered by policy because we are funded to provide innovation. Even on the market, innovation in the energy sector is the biggest part, I would say, triggered by policies. And that's what we call induced innovation. It's innovation that is goal-oriented and the goals are set by the policy. Now, for this innovation to happen, there's one important point. The new technologies that are to be used have to be profitable. If this is not the case, they will never diffuse in the economy. If we cannot pass this test, new technologies will not diffuse, will not become widely used. So what is profitable depends strongly on market conditions in the long run, and in the short run on the policies supporting innovation. And in the energy sector we have a kind of a mix, because we cannot talk really about a free market. Energy markets are strongly regulated, so whatever happens on energy markets, what kind of technologies are profitable, what kind are not so much profitable, that depends not only on market conditions but on energy policy. Now there are different kinds of policies, and from an economic perspective we can group policies in 3 main fields. The first one are taxes or subsidies, the feed-in tariff that we have in Switzerland to support renewables. Standards, for instance, California has, just we talk about storage, introduced a requirement for utilities to provide some storage to the overall system. That's a kind of standard. And then we have market-based solutions, something like a renewable portfolio standard, white certificates or tradable quotas for renewables. That's what we call a market-based policy. The important point is that these policies have hugely different impacts on technological progress. If you talk to people that are involved in making policies, these types of policies are seen as kind of substitutable. What is used in the end is often the outcome the question what is most convenient to get through the political process. But they have huge differences in terms of what kind of technological progress we will see. And the first one is that the speed of progress depends on costs. The more costly it is for firms to use the old technologies, to maintain the use of the old technologies, the faster technological progress will be. That's fairly simple economics. That's a message that's not listened to very well on the policy side. If we want to have fast technological progress, we have to impose huge costs by energy policy. Then firms will search for new technologies. The second difference is that the direction of technological progress differs between different technologies. And to illustrate this is driven by risks. If we talk about how profitable a technology is, this depends, for example, on the price of alternative technologies, for instance, on the price of fossil fuel-powered technologies. And here you see the oil price, the black curve, as an example. And you see this price is highly volatile, so in some years a certain technology might be profitable, in other years it might not be profitable. And that's a risk that all firms investing in new technologies have to bear. On the other hand, on the right-hand side from your perspective, you see a policy-induced risk. This is a price for CO2 emission permits on the European market during the first year of this market. And you again see it's a highly volatile price. There are huge risks. And this is a risk that is imposed by a policy, by a market-based policy. If we would have a constant tax on CO2, firms could plan with a constant price, with a constant tax that's set for the next 10 or 20 years. So this is a risk that is induced by policies. And the important point is firms react to these risks. And this is a project that has been ongoing for, I think, 5 or 6 years now, which is now pushed into a new phase by the SCCR, where we look at what kind of policies induce what kind of risks and how firms can react to these risks. And what we see, I'm not going into detail here, what we see is that different policies lead to very different technologies being adopted. A tax, for instance, yet sets a huge incentive for firms to use flexible technologies, flexible from an economic perspective, that is, technologies where investment costs, where the share of investment costs and total costs is not too high, where I can save money by not using the technology for some periods of time, by switching on and off. On the other hand, standards, on a standard where I have to meet the same standard in every period, such flexibility has no economic value, so I will move to different technologies. So that's an example of what we do as kind of basic research. How does the innovation process work and what is the outcome? And what's a link to energy policy? Let me give you a second example, energy demand. If we talk about storage, we talk about, in the end, what and when do consumers, how much and when do consumers demand energy? And how much energy a consumer demands depends on a huge number of things. We know it depends on income. And we can see it for almost all industrialized countries. If we increase income, consumers want to have more energy. In Switzerland, we have a kind of decoupling at the moment, but in most countries we see not a one-to-one ratio, but a strictly positive relation here. Then we have the impact of prices, of course. If we increase the price of one source of energy, this source of energy will be used less. Well, that's simple. Then we have existing buildings and appliances. How much energy you demand depends on where you live, how you live, and what kind of building and what kind of appliances you possess. It depends on the lifestyle, whether you are a kind of urban family living in Basel or a retired couple, 75 years old, living in Uri, makes a difference in terms of your energy demand. The lifestyle is important. Social norms, is it normal to switch off the light if we leave a room, or is it normal just to keep on lighting your house even if nobody is there? So social norms, individual values play a role, and that could increase this list for a long time. The important point is that we know almost nothing about these influences. What we know is the influence of income, and what we know is the influence of prices. And both of them, what we know, is not too good in terms of the targets we want to meet, because we know more income leads to more energy demand. So the policy implication would be, if we want to reduce energy demand via this pathway, we should get poor. Not a great policy implication. Don't think it's a good idea to communicate this. The other alternative is to increase prices. The problem here is that even in the long run, and long run means 10 to 30 years, it's really long run, energy prices have a very limited effect. If we increase, let's say, the price for electricity by 10%, we see a reduction of electricity demand between 6 and 10%. So if we want to save a lot of energy via prices, we have to increase prices by a huge amount. And it's rather questionable whether this is politically feasible. So we need other policy measures, and this research stream is about finding those policy measures. In addition to just decreasing demand of energy, it's also important to make energy demand more flexible. Perhaps if you talk about storage, that's not your priority, but it might be a good idea for Switzerland in total to have energy demand in some way adjust to energy production. But consumers are typically isolated from price fluctuations. We see 1 or 2 prices per day, and the price for electricity that we pay is the same price on a sunny day and on a cloudy winter day. So there's no incentive for consumers to use more electricity on a sunny day and less electricity on another day. And if we want to have this flexibility, we need to change this in some way. Now what we do is, at a first step, try to understand energy demand. And there are 2 ways to do this. First, we will hopefully start a big survey next year, where we regularly, frequently, every year ask between 10 and 20,000 households in Switzerland regarding how they live, what kind of appliances they own, what kind of energy they demand, and so on. So we really want to know what's going on. The other side is to do lab experiments, psychological experiments, to understand the decision process. How do people decide if I want to buy a new fridge? How do I decide for a certain model? The idea is to understand behavior. That's the very first step. The second step is then to look at what is technically feasible, what kind of efficiency increases in buildings are feasible. And if we combine this, we can develop a model that's able to predict behavior, where we can say, if we make these changes in electricity markets, for instance, this will be the outcome in terms of total energy demand. So that's the second step, a demand-side model that helps us to predict behavior. And finally, if we find some policies that might work, the third step is then to go into the field, make field experiments together with cooperation partners to see what kind of policies are able actually to change behavior. This research design will help us to understand and predict energy demand, not just on a national scale, but also on a sub-national scale. For instance, on a cantonal scale, that is, we will be able to say not just how much, but where energy will be demanded in the future. It will enable us to assess policies for reducing energy demand and assess options for making energy demand somewhat more flexible. Finally, a third example, the question of market design and energy supply. And if you look at these examples, the first one was basic research, the second one is empirical research, the third one is simulation-based research. There are several different methods behind this. What we ask here, that's a new project we just started 1 month ago. What we ask here is how do different instruments that we have on energy markets support for renewables? market liberalization, grid tariffs, the potential introduction of capacity markets. How do these instruments interact and shape investments incentives, for instance, in grids or storage? What we use is a simulation model for Switzerland. That's a bottom-up model where that includes all main power stations in Switzerland, the grid topology, and it includes the main rivers, so that we have the correlation between hydropower production in this analysis. And it's of course linked to SCCR theories and supply of electricity, and it's linked to our macroeconomic assessments. And it allows us to quantify different policies. Just to give you an example here, that's one outcome of this model, what might happen with electricity prices in Switzerland and the neighboring countries. That's a simulation based on the extension plans of the European Union and the plans in the Swiss Energy Strategy 2050. And what you see, electricity prices are likely to increase. And the interesting point is this is mostly driven by CO2 policies, climate policy in the European Union, because that sets a price for CO2, and this price will define what is the marginal unit that's producing, and that defines the price, the supply price for electricity. A second example, what we do with those models is looking at what happens if some things are delayed. For instance, one project that has just been finished is looking at a delayed grid extension in Switzerland. What is going to happen? You see here those colored graphs. The blue one is a base case. Everything in the EU, in Switzerland, is developed as planned, and the purple one, that's a bad case where everything is delayed for at least 1 decade. And you see there quite interesting changes. For instance, to Italy, transfer from and to Italy will not be affected at all, whereas the transfer to France will be hugely affected by different grid extensions. So that's a kind of work we are doing in CREST. These are 3 examples. And as I said, they are not representative. Overall, we have a roadmap. I said we work on 3 topics: energy consumption, promotion of renewables, and assessment tools. From out of this roadmap, I think for storage, if we talk about reducing energy consumption, there are 3 important parts of this roadmap. First of all, the 2 parts on the left-hand side here that help to understand what drives energy demand. And then the middle one here, intervention studies, where we hope to be able to really do changes in the field, examine these changes, analyze them, and that would be, if we start a big intervention project, that would be a good opportunity for cooperation. If we talk about promoting renewables, I think there's one work package that should be ideally suited for collaboration, and that's our task on strategies for smart regional energy systems. If I understand this SCCR here correctly, you look not only at technological storage options, but also at the system perspective for storage, in particular at local storage. And this is something where we might try to work together in the future. And finally, if we talk about assessment of energy policies, we do not just do an assessment of policies. What we offer to all technical SCCRs, once our models are up and running, is to make assessments of economic impacts of new technologies. So if you have some bright new ideas, what could be done, and have some idea of what would be the costs of these technologies, this could be plugged into an economic simulation model to see under which conditions, what kind of market conditions are necessary so that this technology will become widely used in the future. And perhaps we might end saying, okay, it's a great technology, but don't expect a huge impact for Switzerland. That might be a negative outcome. So, summing up, where do I see connections to what you are doing? And I see two main connections. The first one is that we do a lot of work that in the end will define in a certain way what shapes the demand for storage. We talk about demand, we talk about supply, we talk about investment in infrastructure in CREST, finding out how these things depend on energy policy. And in conclusion, we get a lot of information on what is likely to happen in terms of demand for storage under different policy scenarios. The second way where there might be a connection is that we also have a big work package where we look at the innovation process, how to bring new technologies to the market, what kind of new business models might be successful, and what kind of strategies might be rational on the regional level for smart energy regions. So I think these are the two main options if we want to collaborate in the future, and I think a lot of collaboration is already going on. So thanks a lot for having me here, and if there are any questions, I'm happy to answer.